Okay. Yeah, hi, I'm Benjamin. I'm from Lindqvist. I'm here to talk about embracing open source and embedded development. And yeah, this is me. I'm a dad of two. I'm a professional gambler turned mathematician turned embedded developer. Co-founder of the company that was sponsoring this event. We're out in the hall. I'm an Emacs breed. Pretty regular Zephyr RTOS contributor. Yeah, this is our company, Lindqvist. We're a small team of experienced embedded developers who help idea holders in all stages of product development, from architecture, systemization and planning, to circuit board design and firmware hacking. So the company was co-founded by 4 of us in 2022, and we're currently at 11 people. And we do projects almost exclusively in-house for smaller clients, which means we have more like a holistic responsibility. So we do a lot of like architecture work and stuff like that, which is, or I guess you could say we could be qualified to speak on this matter of like software architecture. So we have about 20 active projects now, 4 of which are being manufactured right now, and several successful launches behind us already. And this is what I'm going to be talking about today. So this is what embedded used to be. It used to be pretty simple. It used to be mains powered. It used to be like a pretty simple code, not a lot of concurrency and networking and all that stuff. Just pretty simple control loops, simple serial protocols like RS-485 and stuff. It used to be like, by tradition, hardware skills were more important than being a good coder and having a feeling for software architecture. And this is like changed very dramatically with the Internet of Things. Now you have like small form factor boards. They're battery powered. You have very advanced sensors. You need like an IP stack, connectivity, crypto, all that stuff. And there's also like RF compliance issues and everything, like legal stuff. So it's just way more complicated, way more complicated. And on top of this, it's often like cellular, and you need like years of battery life. So it's not easy. But still, you need the requirements on robustness are the same because it's still headless. It's still an embedded product, which you can't just lift the hood and fix whatever the problem is. If something breaks, it needs to be super robust. But you still need to be faster than ever, like developing it. So this is this is an example project. I don't know if I would call it typical because it's very on the complex side for sure. It's for a customer that does waste level monitoring and stuff like that. So it has an LTE modem, it has Bluetooth, it has a dedicated Wi-Fi chip, and it uses a 60 gigahertz pulse coherent radar for level sensing. It has an accelerometer with a gyroscope and an ambient light sensor. And there's even some variants that use NFC and LoRa and stuff like that. So it's very the battery requirements are like 10 years. And all of this needs to be done on an SoC with 256 kilobytes of RAM. So it's not easy at all. So I think everyone here understands that it would be pretty stupid to attempt this without open source. But people still do it. Like you see it all the time. Like you write stuff from scratch, and it's pretty crazy. It's much more common than one would expect. And it's not like until now in 2025 that it's beginning to become slightly more mainstream to use Zephyr and all that stuff. So Um, but like I said, we have about 20 projects, many LTE based, and we managed to make it work. And I would say there's 0% chance we would be able to do this if we didn't embrace and leverage open source absolutely as much as you possibly could. So rapid prototyping is a very big part of this. So then this is basically the pipe dream of rapid prototyping. Like it would be so cool. It's not really reality, but this is like the pipe dream. Then you have a breakfast meeting with a customer. They explain their specs loosely, and then they can return to you at the end of the day, and you can basically be done. Well, not done, but you can have something for them by the end of the day. And sometimes we actually manage to succeed with this. And it's not just time to market is important because it has business value for the client, but there's other perks with it as well. Like you can use it to gauge feasibility of the project early, and like establish should we even do this, or should we forget about it? And like by bringing something to the customer early, you can force them into like a more agile state of mind. You can basically force them to drop this big design up front thing that people are doing, because it's obvious that the benefits of being agile. And there's also the issue of like building trust and confidence, both for us as a consultancy, but also for the client to bring stuff to his or her higher ups and his or her stakeholders, and ensure that we want to do this thing. And it's also fun. It's like probably the funnest job on earth, being an embedded developer, especially when you get to work with like new and cool tech, and you get to think about architecture and stuff like that. So, and what is the secret sauce then? It's obviously one of the components is open source, like leveraging open source, stealing work from others. It's a massive time saver, obviously, but it's also a little bit of like common sense. And what I mean by that is basically, it's not just reuse, but it's also like picking the right components to reuse that like further enable further reuse, so to speak. And I think like the open source community is pretty good, very good at number one, and maybe a little bit less good at number two. Well, like the proprietary community. They're not a community, but if they were, they're pretty bad at both, right? But I think that's the key to our relative success, so to speak. And this is one example. It's not even a software example, but it's an example around like, if you're rapid prototyping, you want to like build something really fast, so you want to interface your SoC with different peripherals and stuff like that. So it's really helpful if you have like an ecosystem, like a standard to build the interfacing around for prototyping. So what you do is you take a development board, plug in one of those, and you have your peripheral. And we landed on this PMOD standard, which is, it's a really simple standard. It revolves around like these connectors is basically just lab jumpers, 0.1 inch pin headers, and there's some PDFs, very short PDFs on like how to order the pins, essentially for UART communication, SPI communication, stuff like that. And there's nothing really brilliant about it, and that's the brilliant part of it. And yeah, as I said, there's PMOD breakouts for like basically everything. So you can like, if there's a customer requirement for something, you can usually find a PMOD breakout for it. And if you can't, you can design one yourself in no time. If you do, you've added to the existing ecosystem. And I've even designed a PMOD, not being a hardware guy, I've designed some PMOD boards myself. So it's a simple standard, which is why we chose it. Because as you can see, there's many there's many different standards for like board-to-board connecting stuff, simply for rapid prototyping. But you can see some examples here. So this Whisk Connect. I'm not sure about the pitch on it, but it's a very sort of annoying and cumbersome connector to use. And then you have the Quick, which is more sane. It's based on like a very accepted standard, the 4-pin JST. But we just decided basically they're not stupid enough like to build an ecosystem around, because it's like they don't attack the lowest common denominator well enough. So that's why we chose PMod. And this is basically the point. Like if you want to build a community around something, build traction, have people, you need people to be able to agree on the API. And like the more complicated and involved you make it, the less easy it is for people to agree on it, right? You know, so hopefully if it's stupid but simple, people won't agree with it anyway. But the potential is there. If you make the API simple, it's much more likely that people will agree on it. And like there's very little to disagree about regarding like 0.1-inch pin headers, because it's so incredibly universal, right? So that's basically what we do. We do this. We have developed our own like PMod host boards. We're not trying to sell you anything, but just as an example, we're happy to share them. I think they're open hardware even. So if anyone's interested, and we have our booth outside if you want to take a closer look. But that's basically what we do. We take one of these boards, chuck in some peripherals, PMod breakout ports, and start hacking firmware. And the whole process is very smooth and very, very fast. Sorry, my mouth gets very dry. I'm not a very experienced speaker, so I hope that's okay. But here's another example. Like device-to-cloud communications and IoT is usually in most projects it's very cumbersome and design-heavy, and there's a lot of people that need to agree on the the protocols and the schemas and everything, like when and how to talk, like which RPCs you allow, and which usually very, very cumbersome and lots of opinions in the mix. And what usually happens is it's a major time sink for most IoT projects, the cloud communications aspect. And like what you would like to do is really, you would like to pick something that people are familiar with, like a front-end or back-end developer, and they're very used to setting up a microservice and having you chuck JSONs at them. That's what they're familiar with. But it's not really feasible for many reasons. JSON is too bloated, and like HTTP is TCP/IP based, and some operators even, when you're using these new novel power efficient IoT protocol, radio protocols, some operators even, they actively discourage you from using TCP/IP, and some even like to the point of banning it almost, and like disallow it. So it's not really feasible to use these like very common protocols for IoT. So there's some options here how to solve this, but I think that basically the best option is not just dropping them and going with something else, but instead like looking for ways on how to still leverage these very low common denominator familiar APIs such as REST and JSON, and like try to shim into it instead of building something new. So this is basically what we did. There's other options. There's something called lightweight end-to-end, for instance, which I will mention briefly shortly. But this is what we did. So we leveraged some open standards. One is called CoAP, which is basically, it's a UDP equivalent of HTTP. It's almost made to be like a one-to-one correspondence with HTTP. And then we use CBOR, which is designed to be almost one-to-one with JSON. It's supposed to be a lot more compact. Yes. And we combined this with something called CDDL. I don't remember what the acronym stands for. Concise something description language. But you can use these CDDL files to describe your payloads and just chuck them into your build system in Zephyr, and encoders and decoders become auto-generated. And like you can make with CDDL, you can further optimize bandwidth by using some tricks, because you have a schema here, apart from unlike JSON. So you actually have a schema, so you can cheat on the protocol spec in order to save a few more bytes of bandwidth. And there's very, very easy conversion between JSON and CBOR in the cloud due to open source components. And then we built a generic Shin script, essentially a Python script in the cloud, which converts this bandwidth optimized CBOR and CoAP to familiar and humanly readable and just generally nice JSON that gets pushed up to their REST server. This is an example of what CBOR looks like. I didn't want to bog down the presentation with too much technical detail because you just sort of doze off. But here's an example of it at least. And there's a site called CBOR.me that you can play around with if you're curious about it. So yeah, with this setup, you get the best of both worlds, I think, because the device gets to use protocols that are optimized for the situation that we're in, very low RAM, low bandwidth, stringent power constraints and stuff like that. But for the customer, it's basically just interfacing, presenting some other microservice just like any other. And with this approach, everyone who standardizes around JSON and REST, we can just steal the work from them because, for instance, in FluxDB or something like that, they probably have some, JSON REST bindings that you can interface with. So the step from pushing data from the device to the cloud and, the added step of getting it into some database for visualization and stuff becomes very natural because it's all very modular due to this standardizing around common, simple APIs. So it's worth mentioning there are other ways of doing it. It's sort of seems like I'm stating very obvious things here, right? But there are definitely other ways of doing it, such as there's a protocol stack called lightweight M2M, lightweight machine to machine, which is an open standard. And it has gained a certain bit of traction over the years. It's a very complete specification. It defines basically everything for you, how you address your objects and the resources in those objects, how you do firmware upgrade, how you, everything. It's very comprehensive. And it's way more turnkey than, relying on this pretty loosely defined CBOR to REST framework that we used. And yeah, I even evangelized about it at some point, a few years ago, 5 years maybe, something like that. And I dropped it. So that's pretty interesting. But so why? And I would say it's because it's very much of a turnkey black box. It's not bad, it's very good. If you could build traction around it, it would be the natural choice, but it turns out it's very hard to build traction around it because it's very opinionated and very specific, and you need to do things their way. And like with most black boxes, if something breaks, it's very hard to just pop the hood and look around and see what happened. Because it's just such a big, complicated mess. So it's never as turnkey as you would hope, at least not in embedded, where there's like C implementations and there's bugs everywhere. And so the ability to actually pop the hood and look underneath and actually troubleshoot yourself is worth a lot in my mind. But also, since you need to be very lightweight M2M if you're using lightweight M2M, it's pretty hard to expect like a graph data, like a data visualization library like Grafana or Influx or something, or Postgres, to like offer off-the-shelf bindings that interface with lightweight M2M, right? It just doesn't exist pretty much. While with by standardizing around simple JSON and REST, it does. And so yeah, that's basically the lesson. It's you can build stacks around stuff that aren't well-known primitives. You can build stacks that are very opinionated, obviously, but there's also a lot of perks to be had by sticking to this like compositional principle of using well-known simple primitives. So this is an idiom or whatever that is usually sort of said in a slightly disparaging way, right? It's when all you have is a hammer, every problem looks like a nail. It's usually very disparaging. But I sort of like hammers. We'll sort of look for those hammers actively when we develop IoT projects. Like we always say, you should use the biggest sledgehammer you can find to solve a problem, because you usually deploy that exact same solution to some tangent problem. So I think you can flip it around, this idiom, and look at it as sort of a good thing. Like if every problem looks like a nail, all you really need is a hammer. A very well understood tool, right? So yeah. Yeah, and I don't think this philosophy only applies to firmware. Well, as you can see, it also applies to hardware in the sense of PMOD for prototyping. But I think we try to apply this philosophy to everything we do. Essentially, just try to reuse components as much as we can. And I think the different aspects of embedded that aren't software-based are like very rife with opportunities to do this kind of thing. And as I said, we have our booth outside, and I think we'll be more than welcome to look us up, and we can show the actual hardware and some stuff we've done with it. Like for instance, with hardware design, we worked with KiCad. What do you say? Is it KiCad or KiCad? KiCad. And there's a lot of software automation. Like generating manufacturing files automatically and doing design checks in CI/CD. You can generate like bed of nails automatically, semi-automatically, I'd say, for production testing and stuff like that. Mechanical prototyping as well. And our latest thing has been like trying to unify production test equipment, which is something that production testing is essentially something that every, at least every successful IoT project will have to face at some point, because you need to produce the thing you actually intend to sell. So there's lots of interesting things going on there as well. So swing by our booth, and we'll be happy to talk about it. Yeah. That's essentially what I prepared for you today.
Questions? Questions? Ah, right. So I'll get you first. Thank you.
Probably a question that I was going to ask you in a way, but since you're using a lot of open source and you're dealing with connected devices, how are you handling the current, how are you going to handle CRA in relation to your products and your prototypes you're presenting to customers? Since once it leaves the prototype stage, it then has to comply, at least by next year, it has to comply with both the software bill of materials and other processes.
Can you repeat the question?
How are you looking into handling the CRA when it comes, when part of it comes into effect next year?
Very interesting question. I'm not sure I'm familiar with it. What's the acronym? Okay. Yeah, I guess it's the same. It's the same principle, really. Like what we're using open standards, relying on other people's work. Right? It's we don't homebrew, obviously. Use TLS. We try to stick to the latest versions we can, and try to keep updated on the exploits and everything. And
the reason why I'm asking is because the CRA doesn't really care about if you're using open source about the security side. It places all that responsibility on the manufacturers themselves, so that they have done all the work necessary, because they have to audit their product that's being placed on the European market has to be audited to be in compliance with CRA. So if you're using open source components, you are still the one responsible, this company responsible for the compliance, not the open source library to their extent, unless there's libraries presented as a product on the European market.
For sure. Yeah, and I would say, I wouldn't say we haven't felt the effects of that much yet, of customers actually being all that worried about it. But I would say it's also like, okay, you can't push the responsibility on the open source library, but I would say it's a lot easier to argument for the resiliency of the component if it's the same component that you use in a billion other projects and other people use around the world. So, I mean, there's value to it still, I would say.
Traditionally, developing hardware is waterfall style, where you need all the requirements beforehand and you can't really do any mistakes. So how do you implement agile in developing hardware in AUV?
Yeah, good question. I would say that they do a ton of mistakes when doing waterfall. It's just that they're bad, It doesn't mean they don't happen. So you always end up revising the specification, or you end up, or even worse, you wish you could, almost without fail when something is as complex as this. I think I have an example here. Yeah, with something as complex as this, and they changed the specs so many times. At some point they had GNSS. At some point they dropped that. Wanted to do ultra wideband. At some point they, and now we're at the current final solution when they use like combine Wi-Fi and LTE for positioning instead of those two things. And it's a pretty prime example of it. Like what would happen if this project was waterfall? It would be awful. It was still slightly awful. it would have been completely impossible if you did it like waterfall, big design up front style. So it really does enable. Enable smaller players to get involved, like that can't afford to do as much design up front. They need to play around because they don't know what will work. I don't know if that answers the question or not, but
quite good.
Excellent. Thank you very much, Benjamin. Much appreciated. And I think we'll have a few minutes before the next call starts. Okay?